Good evening. I'm Spot On Weather meteorologist Matthew Euler. And tonight I'm doing a video and I'm mainly going to be highlighting all of the changing weather that lies ahead of us. Now, I will say this, it has been very disheartening, especially if you like cold and if you like snow, you like some sort of winter weather. The last 30 days have been fairly mild across southeast Virginia and the East Coast as a whole. Very mild, in southeast Virginia, for example, we had temperatures on New Year's Day morning, January 1st, 71 degrees Fahrenheit, waking up to 71 degrees Fahrenheit on New Year's Day morning, the 1st of January 2019. So we are going to be taking a good look now on this long range video forecast. I want to put this special video together. It's been a while since I made a video. You see the image here on the left of a gentleman walking in some heavy snow with an umbrella. And on the right, you see this family there just bundling up, embracing themselves with very cold air. So we're going to talk about a few factors that we're looking at in the future here that is really going to change this pattern from a mild temperature pattern across the eastern United States to a very, very cold winter pattern. And so let's get started and we're going to go right into it. Now, factors for the upcoming pattern change to colder air across the eastern United States. What are we going to talk about tonight in this video? All right, we're going to talk about the Madden-Julian Oscillation, the MJO, that moving to a phase 8. Now, we've been very mild again for the last 30 days or so, and that's because we've had a very active Madden-Julian Oscillation. We've had a very active Pacific jet stream, but whenever the Madden-Julian Oscillation is in phases 3 and 4, it tends to be very mild across the eastern United States. And so we were in highly amplified phases 3 and 4 of the MJO for quite some time throughout the month of December 2018, which led to very mild conditions. We are, however, finally moving around into the colder phases of the Madden-Julian Oscillation. Phase 8, and I'm going to show you the latest forecast, the GFS forecast here as part of tonight's presentation. Another factor that we like to look at is stratospheric warming and also the polar vortex split. And Dr. Judah Cohen, he has done some amazing research. You can find him on Twitter. Just if you go to Twitter, just type in the search box Dr. Judah Cohen. Amazing work with atmospheric environmental research, AER. Just tremendous work. I've learned so much from Dr. Cohen. Just recently, I've been doing a lot of research, reading a lot of research papers on stratospheric warming of the polar vortex and whether it be a displacement or a split. And what type of weather does that usually follow those stratospheric warmings, polar vortex displacements or splits? So we're going to talk about that tonight in the long-range forecast. We're also going to take a look at the Arctic Oscillation, the AO, going negative. Okay, that's very key in the eastern United States in the wintertime when you get a negative Arctic Oscillation. That's usually an indicator of much colder weather across the eastern United States. And then we're going to talk about the polar front jet stream configuration. We are looking at a change in the overall upper air pattern at about 30,000 feet where the jet stream resides, where we're looking at height rises out in the western part of the United States and height falls further east. All right. And that kind of goes into the theory of what goes up must come down. Okay. Or Newton's law, for every action there's an equal and opposite reaction. So the first thing I'm going to talk about is the latest Madden-Julian Oscillation forecast and how it's projected to go to a phase 8. On the left-hand image, I have the latest. This is the NCEP. This is actually the NCEP GFS, Jeff's run. You notice the solid green dark line there. We're currently on the border between phase 6 and phase 7. And if you follow that green line, around, we're heading generally for a phase 8. And most of the models now, those little yellow lines on the image there on the left, those indicate many different models and their projections of what may happen with the MJO forecast. And we're looking at a transition to a phase 8. On the right-hand image, I'm showing you temperature composites for January, February, and March. The blue shading indicates colder than normal, below normal temperatures, and the oranges and reds indicate above normal temperatures. So if you look at, for example, the warmer phases are phases 4, 5, 6, and even 7 is somewhat mild. You see the orangish and yellowish colors. Now, when we go to phase 8, you see more bluer colors. That's the very bottom right-hand image there on the slide. The very bottom right-hand image, it's bluer colors. And then you got phase 1, phase 2, phase 3. So phases 8 through 3 generally yield colder than normal temperatures across the eastern United States during the winter time. Okay? And we're looking at January, February, March more specifically here on that temperature composite, what you typically get. So the first thing we look at in the long-range forecast is, okay, the Madden-Julian oscillation is forecast to go to phase 8. Okay? That's going to indicate colder than normal temperatures. Next, stratospheric warming and the polar vortex split. Now this polar vortex, just do a Google on it. This has been very big news since late December. There's been a lot of media outlets talking about a possible polar vortex split and a very brutally cold January. All right. Again, Dr. Judah Cohen has done some amazing work on this topic. Now, I've looked at some of the research papers Dr. Cohen has put together, and here's a couple takeaways that I got from his research. First of all, the actual temperature effects felt here at the ground where we live, they generally take a good 2 to 4 weeks on average before you really start feeling the impacts of a stratospheric warming. Now, what exactly is a stratospheric warming? Take a look at the image on the left. And this is from the 18Z for January 2019 GFS model. And you'll notice the reddish and whitish colors there on the left-hand diagram. Now, those indicate excessive warming in the layer of the atmosphere known as the stratosphere. Now, the stratosphere is, again, the second layer. It's not the sphere that we live in. The stratosphere actually is quite some distance above us. But what happens is when you warm up that second layer of the atmosphere, the stratosphere, to excessive levels, it ends up causing some rapid warming, and it sends down energy pulses from the stratosphere downward to the troposphere where we live. And whenever those pulses of energy get transferred, you notice the reddish whitish color here on that image on the left? That shows you excessive warming over the polar areas. And whenever you have excessive warming over the polar areas, you typically get a displacement of the coldest Arctic air. It gets displaced off the polar areas and it moves southward towards the middle latitudes where we live. So this is a good indicator. It's been done by extensive research. Typically Europe and the eastern United States, eastern Canada, eastern United States typically have the coldest temperatures 2 to 4 weeks after a stratospheric warming event. Now, what happens when you send all these pulses of energy from the troposphere, the layer of the atmosphere where we live, up to the stratosphere? The excessive warming happens, a lot of energy bursts occur, and it breaks down what's known as the polar vortex. The polar vortex is simply an area of lower pressure that usually resides up over the polar areas. And when it's strong, and when it's not disturbed by stratospheric warming, then that polar vortex tends to sit there up over the poles. It remains up there, and it keeps the most coldest Arctic air bottled up over the poles at the same time. But when the stratospheric warming effect happens, you get these strong energy pulses that propagate from the troposphere to the stratosphere. It tends to significantly weaken the polar vortex, and it either A, causes a displacement of the polar vortex, or B, it causes what's known as a polar vortex split. In this case, the image on the right shows you oval-shaped and circular-shaped yellowish areas, and those indicate polar vortex pieces or polar vortex lobes. And what these are, in this image on the right, we have one polar vortex lobe or piece situated over eastern Canada, and the other polar vortex lobe is more elongated and oval-shaped, and that's situated over the Norway-Sweden area, okay, more northern European countries. And what happens is the overall placement of the polar vortex is very critical in determining how extensive the cold air gets and how far south that cold air gets displaced off the polar areas. All right, so this is something we got to keep a really close eye on. For us here in Southeast Virginia and in the eastern United States as a whole, if that one piece of the polar vortex, one of those lobes, if it tends to situate itself over Hudson Bay and sag farther enough south, it could really dislodge some extremely cold Arctic air back into the eastern United States. Okay, so we got to really watch this thing, but just keep in mind, stratospheric warming, Dr. Cohen, he's done an amazing job, amazing research, generally leads to a weakening polar vortex. When the vortex weakens, it either gets displaced off the poles or it splits into a couple pieces. And that's when you get really, really cold Arctic air. The Arctic areas warm up excessively, and then as that happens, the colder Arctic air gets dislodged off the poles and sent down to the middle latitudes where we live, here in Southeast Virginia and across the eastern United States. So this is a significant stratospheric warming event which has resulted in a polar vortex split into two main pieces or lobes. Okay, that is an indicator of much colder weather for two main areas in the world, usually Europe and the eastern United States. Thirdly, as a response to the stratospheric warming or the polar vortex split, once you get the energy that propagates upward to the stratosphere, eventually with time, the energy gets repropagated back downwards towards the troposphere where we live, closer to the Earth's surface, and you get a response from the Arctic Oscillation. The Arctic Oscillation typically will go negative with these stratospheric warming events, okay? I've got the circular areas here. On the left, I have the GFS forecast for the Arctic Oscillation, showing it going negative. And on the right, upper right-hand image, all those red lines indicate different ensemble members or models, which show a pretty good decline or decrease to the negative side of the Arctic Oscillation. What happens when the Arctic Oscillation goes negative? These are the typical temperatures you get. And this image is courtesy of the Mid-Atlantic Teleconnections MAD, M-A-D. Typical temperatures you get with a negative Arctic Oscillation for January and February. I have January on the left, I have February on the right. Look at the anomalies, okay? The blue shading, as indicated by the legend or key beneath the maps, shows a temperature departure in degrees Fahrenheit, okay? So if you're a blue shading or aqua shading, generally that indicates below normal temperature. So with a negative Arctic Oscillation in both January on the left and February, the image on the right, it shows that most of the United States is pretty cold with a negative Arctic Oscillation, especially the eastern United States. All right, now I also have associated with these diagrams the different years in which the Arctic Oscillation went negative. And so you can take a look at those and do your own research. If you take a look at some of these years, type in Arctic Oscillation and take a look at some of the previous winters, Januaries and Februaries, and you can take a look and see what the actual temperatures were like. All right, so now we're going to start to get into more of the forecaster discussion portion of the presentation tonight. Now, overall, what's been going on here? Okay, we've been mild the last 30 days, December 2018. We got our first few snowflakes of the season around December 5th. I posted that video on the Spot on Weather channel, YouTube channel. And then ever since that, it has really got mild. I mean, we've had a couple cold mornings, but overall it's been fairly mild. A lot of rain and a lot of mild temperatures. Okay. Right now what we have going on, I'm showing you images of the jet stream, the 30,000 foot level or 300 millibar level charts. If you look at the yellowish colors there, those indicate the strongest jet stream winds. So the legend at the bottom of each image shows you the wind speed and how fast it's blowing. So you got these yellow areas which indicate greater jet stream, faster moving jet stream winds. Generally what you have is more of a west to east. There is a little bit of a dip in the weather pattern here. There's some troughs, there's a dip in the jet stream, but overall, it's been a pretty much west to east, more of a we call a zonal jet stream. which generally results in mild Pacific air moving all the way across the United States from west to east coast. Now, what's going to happen over time? Now, I'm showing you temperatures as well. I like to look at the 5,000 foot temperatures here to kind of give me a clue on what kind of temperature advection or temperature changes we could possibly see. So if you take a look at the charts here, the legend here on the bottom of each of these charts shows you the actual temperatures in degrees Celsius. And you'll notice that the purplish colors and the red and the maroon colors are generally very far to the north over Canada. But the big thing I want to show you here with this is there is a ton of cold air up in Canada right now. Okay, so if that polar vortex lobe were to position itself over Hudson Bay and kind of sag a little bit closer to the US-Canada border, that could really tap into a lot of this cold Arctic air as it's displaced off the poles and really rush south and really invade the eastern United States and make for an extremely cold late January and February period. That's what we're watching closely. But as of for right now, it's mild in the short term because of a more west to east, more zonal jet stream. Pacific air has flooded the North American continent, and you generally keep most of the coldest air up into eastern Canada, which has been pretty cold up there. Okay, now this is going to change. The jet stream pattern is going to change. Now it is a little bit wavy. It's a wavy type pattern here, but look at this image. I want you to go to this image, okay? Wow. The image on the left here shows a major upper level trough, a long wave trough is what we call it, 30,000 feet with a sharp U-shaped pattern, okay? And we get that cold air that funnels in. See, the image on the right shows you the 5,000 foot temperatures again, and you'll notice we have -10 to -14 degrees Celsius air at 5,000 feet that is rushing towards southeast Virginia down the eastern seaboard by the 9th to the 11th of January. This is going to be our first shot of colder Arctic air, and this is going to be quite a wake-up call for us living in southeast Virginia and in the East Coast as a whole, because we've been so used to this mild temperature. So this is going to be a really good shock to the system come Wednesday the 9th. I believe that's it. Yeah, Wednesday the 9th all the way through Friday the 11th of January. So the 9th and 10th of January, Wednesday, Thursday, the upcoming week, look pretty cold. We're talking high temperatures only in the upper 30s to lower 40s. And temperatures at night dropping to low 30s, possible upper 20s, as you move away from the coastal effects, the water across southeast Virginia. Okay, so a highly amplified trough, a digging trough into the eastern United States, the 9th through the 11th. Now this is the first shot of really cold air for the mid-Atlantic, okay? And this is really what's going to start changing this weather pattern that's been pretty mild for the last 30 days. Let's take a look now how the longer range looks. Okay, it's looking much colder. I'm showing you now thickness charts, and the image on the left is, and these are courtesy of Tropical Tidbits. The image on the left shows you the thickness values for the Thursday, January 10th. So it correlates with these images here, showing you the first shot of colder Arctic air, the 9th through the 11th of January. And please forgive me for the 2018. I know we're living in 2019 now, so I meant 2019 there on the year, obviously. So if we take a look at this, though, we have, anytime you see the blue dashed lines in a thickness chart, that is, the lower those blue dashed lines get, the colder the air mass. And so in conjunction with this wavy-like pattern in the left-hand image, you see on thickness charts those lowering thickness values between the surface and about 18,000 feet above the surface. And whenever those values get lower and lower, and you see those blue dashed lines, that indicates very cold air. So we see our first real push of cold Arctic air for the first time in quite some time, the 9th to the 11th of January. Okay, high temperatures again for southeast Virginia in the upper 30s to lower 40s. It'll be much colder the further north you get, especially towards New England. Now, this is another main point I want to make about this whole situation. All right, we're looking at longer lasting cold holding in place over the eastern United States for quite some time. Most of the time we get these quick hitting cold shots that might last maybe 2 days across southeast Virginia, and then they push off into the Atlantic. Now, there's indications that there could be a what's known as high pressure or what's known as a Greenland block developing over Greenland itself, over the Atlantic Ocean. And if we get a strong upper high or a Greenland block in place, what happens is it tends to turn the North Atlantic oscillation negative along with the Arctic oscillation, and you get a stuck weather pattern where you get these deep upper level troughs. And the cold air is so dense, it funnels right into the base of these long wave troughs, and you get these repetitive cold waves, cold wave after cold wave after cold wave. You get these strong surface highs. Look at the image on the left here. I have 1,040 millibar surface high situated around Minneapolis. Okay, you get those strong surface highs with very cold air associated with them. The higher that barometric pressure goes with those surface highs, the stronger and more dense, the colder the air mass. So we have a very good dip or lowering of the thickness values on both the 14th of January and again, the image on the right shows the 20th of January. So I want you to realize that once this cold pattern locks in, it has a real potential to stay in place for quite some time. Okay? And that typically happens again with that research with the stratospheric warming. It generally leads to a prolonged period of colder temperatures across the eastern United States. Dr. Amy H. Butler and Dr. Judah Cohen. If you look up Dr. Amy H. Butler, also on Twitter, she's done some amazing research as well on the topic. And she shares a lot of great information on Twitter. All right, so I wanted to show you this image. This is an amazing thickness chart, honestly. It's a little bit too early to tell the specifics of how cold this air is going to get over the eastern United States, this upcoming pattern change. But this, I've seen a couple indicators, all right? There could be some extremely cold air in late January. We're targeting the 20th of January through the end of January, okay? In this image here, I'm showing you 1043 millibar high situated up near the North Dakota, Minnesota border. And there's a strong push of extremely cold Arctic air. We've got 504 decameter thickness all the way into southern Illinois, going into Michigan. Down here in southeast Virginia, we got about a 526 decameter thickness. In the 540 decameter thickness goes all the way down in northern Florida into the northern Gulf of Mexico. That is impressive cold. In these type of scenarios too, you get these kind of really strong pushes of cold Arctic air, typically along the leading edge of the Arctic air where you get the strongest temperature contrast. That's usually when you get those developments of those nor'easters or those very intense coastal lows. So we're going to have to watch this really closely. These kind of deep troughs, not only with the exceptional cold possibility that's on the table, but also the possibility of wintry weather as far as frozen precipitation, rain, snow mix, snow. This is a really ripe pattern for winter storms, significant ones in the mid-Atlantic. Okay, so this just shows you an image. We typically want about 528 decameter thickness or lower to get snow in Hampton Roads. In our current water temperatures, because the mild air, are still sitting up around 49 degrees Fahrenheit right now. So, but this kind of cold air will drop the water temperatures rapidly, very quickly this time of year, especially with the low sun angle. Now, I want to show you a couple computer forecast outputs. This is from 12Z today, the 4th of January 2019. This is a European temperature forecast. And I was mentioning how the cold air tends to stay in place. It doesn't just come on through the mid-Atlantic, through southeast Virginia, and then pivot offshore. It stays locked in place pretty good. Look at the consistency of the cold air after January 10th, according to the European. I'm not saying this is 100% right, but this is just giving us indicators of what is possible down the line here. 40 degrees for a high on January 10th, 39 on January 11th, and then 43, 44 the weekend of January 12th, 13th. And I mean, it's all sub 50 degree highs here, okay? Average high this time of year in southeast Virginia and the Hampton Road cities is 48 degrees Fahrenheit. So we do have a mild weekend in store, January 5th and January 6th, 2019, very mild. Get out there and enjoy the weekend this weekend. The rain will be moving out. And then we got another little bump up in temperatures. I think this is a little bit too cool, 58 degrees on the European, a little bit too cool for the high on Tuesday, the January 8th. I think it'll be warmer than that, into the 60s. But after that, A cold front moves through overnight Tuesday night into Wednesday morning, and then the temperatures stay cold. Look at the GFS forecast now. This is the GFS temperature forecast. I think the GFS is more reasonable for the high temperature on Tuesday, January 8th. It's going to be mild again. We're looking in the 60s for high temperatures during the day. But then that cold front again moves through. The timing of the cold front, the consistency of the models is there. So starting Wednesday, January 9th, and especially Thursday, January 10th, Friday, January 11th, it's going to get much colder. All right. You look at the forecast for Friday, January 11th, for example. Look at the European, Friday, January 11th, high 39. Oh, look at the GFS, Friday, January 11th, high 38. So there's going to be a higher confidence that the trough's going to amplify pretty significantly along the East Coast late this next upcoming week. Now take a look at the potential here. I was looking at this earlier today around midday, the models. What I see here is the potential for a big East Coast winter storm. Now, of course, this is subject to change. It's way too early. I'm not trying to alarm anybody out there, but with these kind of deep upper level troughs in place, there's a great potential that we could see a significant winter storm developing. The thing is we've had such an active subtropical jet stream already with the weak El Nino. You get these little disturbances that ride along take more of a southern track across the United States, and you get the cold upper level troughs. The image on the right shows the blue shading. Get those cold upper level troughs. So you got colder temperatures aloft. You got moisture coming in from the southwest, and that is a great recipe for a good nor'easter and a fairly significant winter storm, especially this time of the year. Okay, so this is something to keep an eye on the middle of the month for a possible development of a wintry precip somewhere nearby in the mid-Atlantic region. Again, this is subject to change, but this is a kind of weather pattern we are evolving into. Okay, so there's going to be more opportunities for winter events with these very deep, very significantly bouts of cold air. This is what really impressed me today. All right, this is the Climate Forecast System version 2, or what's known as the CFS. And this is the long-range outlook on the CFS. Now, I will tell you something. From looking at the CFS for quite some time, I have noticed a warmer temperature bias with the CFS. Usually, it is completely warm, all right? Now, this is telling me something completely different when I look at it today, all right? And it's not to say that this is not going to modify or it's not going to adjust. The image on the left shows you the temperature departures from normal, okay? Again, I want you to keep in mind the average temperature for Southeast Virginia right now is about 48 degrees Fahrenheit. The image on the left, the greenish and the white and the purplish colors, those indicate temperature departures anywhere from 5 to as much as 12 degrees Fahrenheit below normal, okay? So you can see what's going on here. The image on the left is covering the period 24 January to 29 January. And the image on the right is showing you 29 January to 3 February. Again, this is just showing you, this is impressing me because, like I said, CFS is usually very warm, and I've looked at it so many times, it doesn't really pick up on the cold very well normally. So it's normally very warm, usually too warm from reality. But anyway, this is really impressing me right now, seeing this kind of cold indicated on that CFS, the Climate Forecast System version 2. And again, the coldest period, according to CFS, would be 24 January all the way through the first week of February would be the target of the coldest of the chunk of air coming down from Canada. Here is the final long-range thoughts tonight, okay? Winter is coming. You wouldn't think so based on the last 30 days because it's been so mild. But winter is coming. There are lots of indicators, lots of factors pointing towards a colder weather pattern taking shape across the eastern United States, across the mid-Atlantic, across Southeast Virginia, okay? Longer lasting cold is possible. It's definitely a possibility with occasional outbreaks of extremely cold Arctic air into the mid-Atlantic and Southeast Virginia, okay? The whole eastern United States is looking very cold at times, and I'm talking 15, possibly 20 degree Fahrenheit temperature departures. Even outside the climate forecast system, the CFS V2, there are other models that are indicating it could be even colder than that. I would not be surprised if there were 2 to 3 day periods in which, we're cold for the long term, but in 2 to 3 day periods, chunks of extremely cold air that tend to break off from the poles due to that polar vortex being displaced and split. That polar vortex split, directing much colder air funneling down to the eastern United States. So you're talking the possibility to have a connection from the very far northern reaches of the Arctic down to the eastern United States. That is definitely a possibility with a polar vortex split, as well as all that stratospheric warming which has occurred. Okay, it is going to be mild for Saturday the 5th of January, Sunday the 6th of January. It looks like a great weekend. Rain moves out early Saturday morning. It's out of here. Dry weather. You want to get out there and take your Christmas decorations down outside. You're looking at temperatures, low 60s, possibly middle 60s. But it's going to be great this weekend. It's going to be mild. For this time of year, it's going to be well above normal again. We're looking at about 14 to 15 degrees Fahrenheit above normal during the day. Right? It's also, we're going to have a little bit of a cool down on Monday, the 7th of January, but then it bumps right back up on Tuesday, January 8th. We're again going to be very mild with temperatures into the 60s during the day. I think January the 8th, Tuesday, is going to be one of the last real mild days. And then we get that first appreciable shot of cold Arctic air. That's going to be moving in here from the 9th, 10th, 11th. Those are the main dates. I've watched the models. They've gotten a lot sharper with the amplification, with the deepening of that long wave trough right off the eastern seaboard, the East Coast. So we can have a really cold, a rude awakening with that shot of cold air. But that's going to be that first shot that really, really changes that pattern. Additional outbreaks of Arctic air are possible from 14 to 16 January and then 19 to 21 January. Now that 14 to 16 January, look out, because again, there is a possibility of a major winter storm along the East Coast. The European model has indicated this earlier today, so we'll have to wait and see what happens. All right, but anytime you get these extremely cold outbreaks of Arctic air, you also got to look out for the potential of a very active subtropical jet stream and the development of a low pressure moving up the coast along the leading edge of these extremely cold Arctic outbreaks. We're looking at a very cold late January and February period. This is a very distinct possibility, okay? And the models have trended colder the last couple days on this. And again, I mentioned about the active subtropical jet stream associated with a weak El Nino. It's already been very busy as indicated by all the rain. Southeast U.S. has received all the way up the East Coast, especially the Mid-Atlantic. So we're looking at an active subtropical jet stream continuing. It's going to produce more southern track storms moving up the East Coast, leading to increased likelihood of winter storms, wintry precip. And then Dr. Judah Cohen, again, check him out. He has done extensive research on stratospheric warming events and polar vortex displacements or splits. Please take a look at some of his amazing research. Amazing job. And also, if you want to, Dr. Amy H. Butler on Twitter. I've learned so much over the past couple weeks just researching some of their papers and some of their work on this phenomena. It's really amazing work. All right, that wraps things up tonight. Spot on weather. Special video. Winter is coming. Believe me, it is coming. There's a lot left of winter across the eastern United States. It is not finished. It is not done. So hang in there. If you really want some winter weather, if you're a snow hound and you really want to see some snowflakes, it is coming, folks. It's looking like all the indicators are there. Again, things could change, but it's looking that way at the present time. All right, so that wraps things up tonight. Spot on weather. I hope you enjoyed this presentation. Remember, if we're not spot on, we're not doing it right. Have a great evening, everybody. Take care, and have a good one.